Okay, so I'm going to talk about question 2 from the problem solving section of the homework. I think the problem with this question was that it asked us sort of to generate quite a lot of the information ourselves by our understanding of the situation. So the first question asked us to use a probability argument to deduce that the probability of x equals 30 is 0.4. Now what that means essentially is it wants us to use our knowledge of probability to work out that the probability of x equals 30 and show that it equals 0.4. So first of all, we have to consider the situation itself, and it was that Ben had 5 coins in his pocket, 2 10p's, 2 20p's and 1 50p, and we wanted to find the probability that when he pulled out 2 coins, he got 30p. So the first thing to think about is how he could have possibly got 30p. So he could have got a 10 and then a 20, or he could have got a 20 and then a 10p. If he pulled out a 50p, that would have been too much. It's his only possible options of getting 30p out of his pocket. So we just simply need to consider how he would get those and the probability of doing so. So the probability that the first coin he pulls out as a 10p will be 2 out of 5. Then the probability that he pulls out a 20p will then be 2 out of 4. Because I've already pulled out 1 coin, so there's only 4 left in there. So it'll be 2 out of 4. Because I want this situation to happen, a 10p and then a 20p, I can use the AND rule because they are independent. Okay? So that's the probability of that one, which would be 4 out of 20. The second combination that we could get is a 20p and then a 10p. So the probability of 20p is 2 out of 5, and then a 10p again is 2 out of 4, so this is 4 out of 20. Now because I can get this combination or this combination, I can add them together. So this, add this, and so 2 lots of 4 out of 20 is 4 out of 10, which is 0.4. So we've proven what we've been asked to do. The second part of the question I'm not going to go through because it was a basic version of just working out the expectation and the standard deviation, which if we found the variance, we could square root. So we worked out the variance to be 324 by doing the sum of x squared, take away, not the sum, sorry, the expectation of x squared, take away the expectation of x squared. That would have given us the value of 324, then we just simply square root it to find the standard deviation. But I am going to talk about part C. Part C gives us a situation where Ellie is paying the same as Ben and Charlotte pays 50p. So it's a set amount. It's not a probability distribution because she always pays 50p. So then we need to find the mean and standard deviation of all 3 contributions. So the first thing I'm going to do is set up an equation to talk about all 3 contributions. So if we call the total contribution y, then the contribution that Ben pays in is x. We've modelled that as a distribution already. So Ben will pay x. Ellie will pay the same as Ben. So therefore we will have 2 lots of whatever Ben pays. And Charlotte will always pay 50p. So we would always add on 50p. So that is my equation of the total contributions in terms of how much Ben contributes. That's the only thing that's going to change. Charlotte will always pay 50p and Ellie will always pay the same as Ben. Now I've got a situation which is essentially coding. So if I wanted to work out the mean of the total contributions, I can simply understand that I can do 2 lots of the mean of Ben's contribution, add 50p through my knowledge of coding, and I would have 2 times 44, add 50, and I would get 88 out of 50, 138, or £1.38 if we want to put it like that. Okay. If I wanted to work out the standard deviation, the best way for me to do it would be to work out the variance, because I know how to deal with that in terms of coding, and then just square root it. So the variance of my coded data is simply the multiple of x, but I have to square it. So 2 squared times by the variance of x and I ignore the plus 50p, because when I decode, then it talks about spread. It doesn't matter if I've added onto it, the spread will still be the same. So I ignore this bit here. So I will do 4 times by 324, which will be 1200, add 80, add 16, so it will be 1296, and then I can simply square root that value. So the square root of 1296 will give me the standard deviation, which is 36. So that is the standard deviation of all 3 contributions. Okay. Hope that helps.